January the 14th, 2014. This is the USGS earthquake map. Guys, we've had two unusual quakes at the top and bottom of the earth. Notice that. Both are linked to the mid-Atlantic ridge. Now, the USGS is not showing all of the quakes in the south, and I'll show you that on the RSOE maps. But it's showing two here. Now, the quakes have been centered mostly in the equator region. We've noticed the ones in Puerto Rico, Cuba, guys, things like that. The strongest ones that were there. Now, what would be causing suddenly our stronger quakes? You see the 5.2, 5.8, 5.3 in the Greenland Sea up north. Well, are we getting these now? Well, it could be because of solar activity. Now, they're not that strong, but they're unusual. And this line from the one in the Greenland Sea, guys, comes right over to Japan. If you take this map and wrap it around into the globe shape, again, you've got one circle, and it's all interconnected. And that's when you start to get, you start to notice differences in patterns. And that's what this is. This is a difference in pattern. Suddenly, both ends of the globe connected to the same fault line. Now, at the RSOE, you can see this is showing where it's daytime, this lighter area. Now, let's go over and look. There's the one at the top. You see that? At the bottom here. Now, what the USGS is not showing is that these quakes are moving west up this African fault. It comes off the southern tip of the Mid-Atlantic Ridge. Now, notice as it comes here, we'll look at these quakes. You've got about three there. They're calling this South Africa or the Eastern Cape location, Jeffreys Bay. The other one is at Hummus. This is a South African Western Cape. So they're moving from that central first quake that we saw. They're moving west. Now, how far they will extend, I don't know, but let's look at where these fault lines move. You see here they call that Bouvet Island, and that's what's listed on the USGS as the Bouvet Island quake. 5.2. But you can see the crack in the earth, guys. You see that now. It's going to go west. It's moving east. It's going to move up this African plate. Now, we're already seeing pressure. Earthquake report there. You see that at 4.5, and that's in Iran. But when this quake, this pressure moves up this fault zone, it comes either into the Red Sea or through the Persian Gulf. You see how it splits just below here? I'll back it out and check it. As it moves, and that's the way the direction of these quakes are moving. This is the most rigid line. That's going to take the most pressure. There's a lot of cracks moving to the right. You see that? A lot of pressure relief. So when it's coming up, if it's going into the Red Sea, you can see the direction. Now we already see it that there's pressure again in the Persian Gulf. Now the one that goes through the Red Sea is the one we talked about on Paul Begley's show the other day. It runs right up through Jerusalem. You can see, I'm going to pull it all the way up. And guys, this is moving north and south. But there's a valley that goes east and west that they have this road on, if you want to take the time to look at the closer maps. And when you have mountainous areas, that's where you put your roads, just like in Denver or somewhere like that in the mountains. You don't have a lot of choice. And so what I'm talking about is when Christ sets his foot down on the Mount of Olives. But listen, Africa here is called the province of Western Cape, Constantia, Hermanus, Constantia, 2 each, 5.2s. And I will link to this ROSE because it has other information. It's showing natural disasters, man-made disasters, things like that. Notice this fault moves up through Israel, then moves west under Cyprus, out into through the Straits of Gibraltar. Actually, you see it doesn't go right through the strait, and then it moves north above the Canary Islands, back into the Atlantic Ridge where we had the two quakes. Again, these are unusual. This one's called in Barrettsburg. Now, what happened, guys? We had a CME that came across the Earth today. This is a model, and they're 8 hours plus or minus, but I'll show you the live instrumentation on it. But remember the video from 2 days ago? I showed you both filaments releasing from the sun. This is the pressure that came across the Earth and the satellite Maven in the pink triangle that's headed to Mars to watch comet sighting spring come in. Now, it was not that strong of a CME. There was a spike. Again, I'll show you that on the real time. But guys, it's telling me that the shields are weak. Remember, Michael said that. Our magnetic shields are weak. It doesn't take as much. And the reason because of that, starting with that X flare again, it's been mostly every other day some type of event that has energized and weakened our shields. But look at the spike in the ion density, then the temperature and the velocity, guys. This is from the ACE solar wind data information. Notice the blue line at the top. We're just going into another spike. Now, it may not take much if these shields are as weak as we think. Now, in this scenario, we have an object approaching the Earth with a magnetic field. Now, this is what Michael was talking about. Again, we wouldn't be able to see it in the infrared, but as its magnetic field entwines with the Earth's, how is that going to affect this tilt we're in this extreme weather? Do you see what I'm saying? And as it gets closer, he's talking about lightning storms and energy transfers. And with our shields being weakened from the solar blast, how close will it have to get before we start seeing these effects? There's been other information besides just Michael about some type of energy behind the Earth. We've seen it before. We've seen the magnetopause reverse. Now, there's a lot of scenarios involved in that, the tilt of the Earth. And listen, as we look at the CME that we haven't had to deal with yet, notice it released from the right of the sun there. That just happened today, and we've got not a lot of large solar flares. We're watching them. We still have a filament here that has not released. We watched it come around the sun, but here's the CME, the coronal mass ejection. But in the scenario, the two objects with the magnetic fields that we were looking at, we have to think of the polarity of the object below the Earth. Is its north pole magnetic field matched polarities with the south pole of the sun? That would be the strongest object to be opposite polarities. Or is it the same? And will that push the south pole away from it, shifting the Earth further over that way? Or will it attract the north pole of the Earth? You understand what I'm saying? This is our solar flare, the sunspot summary. Nothing real big. 52 is the largest with 326 on the millionths. Nothing real strong, but they're there, and we have the chance for CMEs. Notice that coronal hole is coming around. That will give us a little heat relief in this cold weather. Australia doesn't need it. We're in an extreme tilt now. It's interesting times, guys. Heads up.